Let's try 11.10. Suppose your body was able to use the chemical energy in gasoline. How far could you pedal a bicycle at 15 kilometers per hour on the energy in 1 gallon of gas? 1 gallon of gas is a mass of 3.2 kilograms. Okay, so there's a couple questions that we need to ask before we even start this problem. Is how much energy is in 1 gallon of gasoline? And so this is actually in table 11.1. So T 11.1. And it says that 1 gallon of gasoline, 1 gram of gas, contains 44 kilojoules. 44 kilojoules. The second question we need to ask is, how much energy does our body use to pedal a bicycle at 15 kilometers per hour? And so this is actually in table 11.4. And we're told that we use 480 joules per second, or 480 watts, at 15 kilometers per hour. Okay, so with this information, we should be able to solve the rest of the problem. So the first step is just to figure out how much energy is in that 3.2 kilograms of gasoline. So let's just do E sub chem for chemical energy is going to be equal to 3.2 kilograms. And then I'm just going to convert this over to joules. So 1,000 grams and 1 kilogram. So this is just to get it into grams, since we're given the conversion of 1 gram is 44 kilojoules. So the kilograms are going to divide out. And there are 44 kilojoules from our table and 1 gram. And then there are 1,000 joules and 1 kilojoules. Because we just want it in terms of joules, right? We're not interested in kilojoules. So these are going to divide out, and the grams are going to divide out. And so when you put this in your calculator, you get this is equal to 1.4 times 10 to the 8th joules. So now we know how much energy is in that 1 gallon of gas. And then we're also told, we're told that we use 480 joules per second traveling at 15 kilometers per hour. So if you remember, we're just going to transform this energy into work, right? And we can use the power is equal to change in energy over change in time. And so power is just joules per second, right? So let's just rearrange this, and we want to solve for time, right? We're going to consume all this energy that's in the gas, which is 1.4 times 10 to the 8th joules. So that's going to be our delta E, because we're consuming it all. And this power is just going to be 480 joules per second. And so if we want to solve for delta T, right, because as soon as we have delta T, we can easily find out how far we can go, because we have the time and the velocity. So delta T is going to be equal to divide P by both sides, and we get delta E over P. And I said that my delta E is just the total energy in gas, right? We're going to consume all of that. So 1.4 times 10 to the 8th joules. And then we're going to consume 480 joules per second. So that's my power. And so the joules are going to divide out, and we're just left with seconds. And this turns out to be 2.93 times 10 to the 5th seconds. And so this comes out to roughly 81 hours. So that's how long we can go, essentially burning 480 joules per second. So now that we have the time that we can travel at 15 kilometers per hour, all we have to do is multiply our velocity times our time. So distance, right, is going to be equal to velocity times time. And so this is equal to, our velocity is 15 kilometers per hour times 81 hours. So hours are going to divide out, we're just left with kilometers, and this turns out to be 1,200 kilometers, which is roughly 760 miles. So this is a very efficient way to travel, right? You can travel 760 miles on just 1 gallon of gas. And so that's 11.10.